Hello everyone, it's Grumpy Gamer. Welcome back to another Tekkit tutorial. Today I'm going to be showing you something I'm very proud of. This is Elevator 3.0. Now I know you've seen elevators before, don't tune away quite yet. This isn't about the elevator itself, it's more like to show you what you can do with Redpower logic. Now I try to make this elevator as realistic as possible, so you can see here this is the control logic for the elevator. So this is not for the faint of heart. If you're totally new to Tekkit or Redpower completely scares you and you don't want to get into it, this may not be the video for you. But if you kind of like Redpower but you're not completely good at it, you want to take your skills to the next level, this will be a very good video, because I'm going to go over every last single part of this circuit. This video is probably going to end up being two parts. Let me go over it first. First thing I like to do when I do a tutorial is like to show how it works. In other words, I'm going to show you this elevator does work. Now, which floor are we on? We were on the third floor. Let's go up here to the third floor, and we hit the call button. Now the elevator is going to start moving. When it arrives, you'll see this light right here turns blue. So we have indicators for all the floors: red, green, blue, and yellow for 1, 2, 3, and 4 for the floors. So the elevator is moving, it's a little bit slow. It takes this thing like 12 seconds to move between floors. But there you can see the door automatically opened for us and automatically closed. And if you listen carefully, you also heard a bell. Whenever this elevator opens or closes the door, it also makes a bell go off. And it also, the bell goes off when we switch floors. So every time we arrive at a floor, the bell will go off. Now let me show you all the buttons. We have an open button, an emergency stop button, and we have a button for every floor: 1, 2, 3, and 4. Let me show you the open button first. Sometimes you get on the elevator and you decide you don't want to use it, you changed your mind. You just hit the open button and you can get back out and then go about your business. So there's the open button, that works. Next thing I'm going to show you is the emergency stop button and the numbers here. This elevator will go to any floor if we just hit the button, but I want to show you how the emergency stop button works. So let's go to floor 2. And that's going to make the elevator start moving. And then I just hit the emergency stop button. As you can see, the elevator stopped. We are between floors. And so let's go ahead and get it started again. Now that's actually part of the reason I don't have double doors. Elevators usually have double doors. I just wanted you to be able to see that we stopped. But honestly, I kind of wish I would have put the second door just to make it more realistic. It wouldn't have been too hard to do. But anyway, that's we covered all the buttons. We got the open button, emergency stop button, and we got the four floors. Next thing I'm going to do is cover the call button. A call button is actually more complicated than you think. If I hit that button, it's not just going to open the door. It doesn't just open the door. It's not, in other words, it's not wired to the door. What this button is wired to is the control logic, and the control logic has to decide what to do. Now if the elevator is on our floor and we hit the button, the control logic says, hey, let's just open the door, the elevator's already here. But if we're on a different floor, like say down here, control logic says, hey, do not open the door, move the elevator. So we have a circuit over there that does all that for us. The next thing I'm going to show you is we'll get in the circuit last. I'm going to show you all the stuff that's on the elevator over here, how it all works. Now if we look right here, we can see some wireless transmitters. You can see some wood logs right here. These logs are connected to the buttons. Here's this interesting thing to note: redstone signals will not go through a support frame, or at least it did it for me. So I replaced them with log blocks, and the reason I chose log blocks is I figured, well, if I'm going to have to put something in there, I want to put something in there that's going to create a high contrast so the buttons really pop. A button on a stone, it's kind of hard to see. On these logs on the other side, you could really see them good. But anyway, if you hit the button, the log transmits the redstone signal to the red alloy wire. The red alloy wire in turn transmits to a frequency. So there's 6 frequencies here because there's 6 buttons, and so if we hit any button, it transmits the signal back to the control circuit. Now here's something to note: these red alloy wires, since they're on logs, they would not be connected to the support frames unless we added this structure right here. You can see these, this right here and this right here. They're covering up the red alloy wire, and what that does, keeps the red alloy wire from popping off when the elevator moves. Without these, what happens as soon as you hit the up button or the down button, the elevator moves and those red alloy wires pop off. Well, this right here, actually, the red alloy wire, I know it's a small wire, but it's actually occupying that block. Well, these right here just make sure it's support frames. Just make sure the support frames are touching the red alloy wire. And so let's go over the next thing. Let's see, what do we got? Oh, we got the top here. First thing right here, here's the alarm, set to frequency 44. Now the button does not actually turn on the alarm. The button goes back to the control circuit. The control circuit turns on the alarm. Next we have this right here. It's a note block. Whenever this elevator switches floors, or whenever the door opens or closes, we hear a tone, and this right here is the note block that makes that happen. Same thing, everything is controlled with the control logic. There are no logic gates at the elevator itself. Next I want to show you is optical switches. I have 4 of them, one for each floor. Now I decided before I even built this that I wanted to try to use optical sensors, because I've never used them on a build before inside Tekkit. And so this is how I did it. You see a little chamber in there. But if we look at the elevator, you'll see an arm coming out the back of it, the 2 support frames, and then this piece of cobblestone. As the elevator moves, the arm moves with it, and the arm covers up the optical sensor. So it tells the control circuit which floor the elevator is on. So let's say, for example, if I tell the elevator to move, the elevator starts moving up. The control circuit knows the elevator arrived when the cobblestone arm covers up this light sensor. So let me cover the light sensor. First of all, I have it closed twice. In other words, it was open and I clicked it twice to close it to that position. But if you see, the light sensor is putting out a signal right now because it's receiving light. I actually want this thing to put out a signal when it's not putting out light, because when it's not putting out light, it means the elevator's here. So in other words, I want the wireless transmitter to transmit whenever the elevator's in this position. So I have to invert the logic, and that's a NOT gate right there. So if you can see the lights on right now, then we got a NOT gate and the transmitter's off. And so the control circuit knows where the elevator's at. Finally, on the elevator itself, I'm going to show you the motor system. Now normally what I do is, as my other elevators, I just had a platform. I didn't have a box, just had a platform, and beneath the platform there was a long shaft, and the frame motors move the shaft up and down to move the platform up and down. Well, this time I decided I did not want a shaft, and so the way I did it this time is I have an arm coming off the elevator. It's right here. Let me get behind it a little bit so you can see it. I'm pointing at the elevator, but you can see there's an arm right here. This is like a bar hanging off the side, or a bracket. Comes out, goes down, and then comes back in. And so as you can see, the frame motors, they don't connect to the elevator, they connect to this bar. The bar moves up and down, and since it's connected to the elevator moves up and down. Well, there's 2 sets of motors. The right side is the up motors, and you can see it right there. There's up. Left side is the down motors. You can see it there. So as always, frame motors need power, so you can see our power right here. There's our Redpower 2 solar panels. We got a piece of blue alloy wire feeding into this battery box. You can see it going in right there. And then finally, we got more blue alloy wire, and this blue alloy wire touches all the motors, so you can see it touching right there. It touches all the motors. And finally, to make the motors work, you need to be able to pulse them with a control signal. So on the right side, I'm using this white wire. This white wire touches all the motors. We can verify that a little bit. There we go. On the left side, I'm using light gray wire. So these are also touching the down motors. So if we look right here, we have a bundled cable now. Anything that's hardwired into the control circuit, it goes through this bundled cable and back into the control logic. So what else do we have here? First of all, we have the call buttons. You can see them right here on the back side. They're using a black, brown, orange, and purple wires. And also we have the pistons for the doors. Now these pistons, you see they're energized right now, so the pistons are extended. That closes the door. So we're having to use some inverse logic here. We want the door to open. We send these pistons a low signal. When we want them to open, I'm sorry, we want them to open, we send them a low signal. When we want them to close, we send them a high signal. And finally, here's another thing to note. You can see this circuit right here. This comes off the control circuit too. This just controls the indicator lights to tell us which floor we're on. Now we have one of these setups on every floor, and we also have it inside the elevator, and it all uses the same frequency, same principle. But you can see it's right there on the elevator too. These lamps right here, these are actually the lamps that you see when you're inside the elevator. I'll show it to you up here though, because it's easier to see. As you can see right now, only one of them's lit. That's frequency 32. That comes off the control logic, and it just tells the green lamp to come on. If we switch to floor 1, this one will go out and this one will come on. But like I said, all these indicator lights, there's no reason to show you all 5 because they're all the same setup. So that's basically the elevator. Oh, I think I forgot to mention a couple more things here. First of all, you can see I got lamps in the ceiling, and you can see Redpower or red alloy wire on top of 2 of them next to a redstone torch. That makes sure all the lamps are on. And again, here's one thing to note: the lamps themselves, they are connected to the support frame, so they're okay. But the red alloy wire would not be connected unless I have this thing over the top. So that's that. Finally, we have a jukebox, so I have it turned off, but our elevator can play elevator music. I just turned it off to the purpose of the tutorial, but let me show it to you. That sounds like some good elevator music. Now, I originally wanted this music to only play while the elevator was moving, but that's not possible because the jukebox does not accept a redstone signal. It is possible to do it with computer craft, but I know very little about computer craft. I know you can do it. I've actually seen a guy do it. Basically, you hook a disk drive to computer, and you put the music disc in the disk drive, and then you write a little computer program that will turn the music off and on. But I didn't want to go through trouble to learn computer craft just to do something like that. But yeah, that's something you might want to think about on your own elevator. If you want to do an elevator design and you know a little computer craft, you can make elevator music turn off and on. Let me show you what disk this is. It's C418 chirp. It's disk 2259. I thought that made good elevator music, but anyway, let's finally get off into the control logic and show you how all that works. Okay, now if you remember, we had buttons on the inside for all the floors. They come out right here. These are receivers. We got 11, 12, 13, and 14, and that corresponds to the frequencies over here: 11, 12, 13, and 14. So when you hit a button, it feeds into the control logic from here. As you can see right now, we're on floor number 2. Now these are memory cells. There's 4 of them right here and another 4 over here. We're going to go over this set of 4 first. Now this might be a little intimidating looking. It's not as bad as what you think, because first of all, it's just a circuit duplicated 8 times, so you only have to learn how one of these works, then you learn how all of them work. It's really not that hard. But let me show you what we're using for memory. We're using RS latches. That's short for reset set latches. So this thing has an input, or it has 2 inputs over here. We pulse this one to set the latch, and we pulse this one to reset the latch. So right now this latch is off. You know it's off too because the lamp's off. This one right here is the one that's actually on. So let me show you how this works. When you hit a button, it comes down here and goes through these buffer gates. You have to have these buffer gates or this will not work properly. But basically, when you hit the button, it's going to pulse these 4 wires right here. And so let's figure out what this would do if we hit this 3rd button. It's going to pulse brown and orange. So let's see what brown and orange do. Brown's going to reset this one. Orange is going to reset this one. Next we got yellow. Yellow is going to set this one, and finally magenta is going to clear this one. And so let me go over the colors here. We got 4 RS latches, so we got 4 memory cells, but each input gets its own color. So we got black, brown, red, orange, yellow, green, blue, and violet. So if we want to activate any memory cell, we just hit the button, and the button does 4 things. Or it turns on the one memory cell and turns off the other 3. So that's really not too hard at all. Now let me explain to you why I have to have these buffer gates. Okay, let's go back over here to number 1. When we hit the 1 button, it's going to pulse the black wire, which sets this one. But at the same time, it's going to pulse the orange wire. Now, if we pulse the orange wire, what it's going to do is clear this one. But let me show you what would happen if we did not have these buffer gates. If we pulse this orange wire, it's going to pulse every orange wire in the system. So if we're pulsing this orange wire and we did not have the buffer gates, this orange wire would pulse too. If this orange wire pulses, it's going to pulse brown, violet, and green. So what's going to end up happening is if you did not have the buffer gates and you hit a button, all 8 inputs are going to pulse on the RS latches, and it's not going to work properly. So the buffer gates are used like a one-way valve. The signal will go through this way. Like say if I hit the green button, if I hit this button, it'll pulse the green wire, but all the other greens will not pulse because this buffer gate, the signal can't go through it backwards. So that's the purpose of the buffer gates. And there's the RS latches. Now there's 4 of them, one for each floor. We got red floor, green floor, blue floor, and yellow floor. The last button we pushed was the second floor, so that's why green is lit. So basically this circuit right here remembers which button you push last. So we have another set of memory cells over here. Now what these are connected to the light sensor. So this set of memory cells remembers the last floor the elevator was on. And so right now the elevator is on the second floor, so this light right here is on. Now here's an important thing to note. This light does not tell you which floor the elevator's on. It's telling you the last floor the elevator's on. That's important to note because watch this. If I actually switch floors, there we go. We just told the elevator to go to the blue floor. The elevator is moving right now, but the green light is still on. The green light will not switch to blue until the elevator arrives. That's important to note. So that we'll get into that a little later, perhaps. Now, if you actually want to know where the elevator is, if the elevator is on the floor, you can look right here. Here we see a signal. We'll get into this in a little while, but you can see right now the elevator is on the 3rd floor right now. So this right here, this point right here, or this point right here, they will tell you the elevator is on that floor. These right here are not necessarily telling you which floor the elevator is on. And so there we have 8 memory cells. One set tells the elevator where it needs to go. One set tells you kind of where the elevator is at. And we need a way to tell the motors what to do with these signals. So we have these 8 signals in this circuit over here. There's 2 of them. Here's one right here. Here's one right here. This one is for the up motor. This one for the down motor. This is the motor controllers. Now, if you remember on the motors themselves, we had a white wire for the up motors. You can see it right here. And we also had a light gray for the down motors. You can see it right here. Now this part's a little difficult to explain. I'll try to do my best. It's kind of abstract, but we'll go over it. Hopefully you'll understand it. I'll go over it a couple times just to make sure, but basically here's the deal. Let's say we hit the button for the second floor. We're telling the elevator to go to the second floor. So when does the up motor actually need to go on? If we're telling the elevator to go to the second floor, when does the up motor need to turn on? Well, the up motor only needs to turn on if the elevator is on the 1st floor. So that would be this right here. Now here's something to note. I'm using bundled cables as data buses. Now there's more than one data bus in the system. This is one data bus. It's only connected to the inputs of the RS latches. Here's the second data bus. This is the main bus. This goes all the way through the system. Goes all the way to, like, right over here to the to the up motor and down motor control logic. But the reason I point that out, if these are different data buses, it allows me to reuse the colors. And so if you look right here, this black wire and this black wire, they are not the same. So in other words, this black wire here could be high, this black wire could be low. They don't necessarily have to be in the same state. And so I can reuse the colors. So now on the output of all the memory cells, I'm reusing the colors. And so let me go over that. We got black, brown, red, orange, yellow, green, blue, and violet. So one last time, these 8 colors right here, it's different than the colors I'm using over here because they're connected to different buses. But anyway, I had to show you that because the output of the memory cells, those colors, they come out over here, and this determines whether the motor needs to go up and down. So here we go again. If we're on the second floor, the elevator needs to go, the up motor needs to come on if the elevator's on the first floor. So this is going to be brown and yellow. So if brown and yellow are both high, we need the motor to come on. And next I'm going to go over this one on the end. What if we tell the elevator to go to the fourth floor? When does the up motor need to come on? Well, it needs to come on if the elevator's on the first, second, or third floor. So let's see what our colors are. The orange, yellow, green, and blue. And so we can see that over here: orange, yellow, green, and blue. And so what's going to happen is, say if we hit the fourth floor button and we were on the first floor, come over here, this orange button would be high, and so would the yellow. Now this right here is an OR gate, and this is an AND gate. And so if the way this works, if yellow or green or blue is high, in other words, if the elevator is on the first, second, or third floor, this OR gate puts out a signal. Now if we hit the fourth floor button, the AND gate, both of its inputs are high, so it puts out a pulse on the white line. And the white line actually goes to the actual motor controls over here. This is just the controller to determine which motor needs to go off and on, but this is actually the circuit to make the motors work. I know it looks very complicated, and it is. We will go over that. Basically, there's times we don't want the motor to come on, like an emergency stop button or things like that, so that's why we have this all elaborate. But anyway, that's how the up circuit works. We'll go over this one more time. So this time I'm going to go over the down command, or when does the down motor come on. So let's say we hit the first floor button. That's the red lamp. That's the black wire right here. When does the down motor actually need to come on? It needs to come on when the elevator is on the second, third, or fourth floor. So let's go see which colors we have over here for that. Green, blue, and violet. So if we come over here, the black is the first floor button, and then we have green, blue, and violet. So this is actually took me a while to figure this out, and it's very complicated. What it is, you can't make a mistake, so you got to go over it and over it, and it took me maybe an hour to make just this little circuit right here. But anyway, next we'll go over the door controls.